This meeting is being recorded.
In this video, we'll take a look at the second half of section 12.1 that covers alcohol nomenclature, because there's quite a bit to cover between alcohols and phenols. And we also can call alcohols or classify them depending on the type of carbon which the hydroxyl group is attached to. And by the type of carbon, I mean, is it a primary carbon, a secondary, or tertiary carbon? So just like our halides that we saw back in chapter 7, when we had a primary alkyl halide, secondary alkyl halide, etc. So alcohols, right? So we'll look at this first example here. So we'll draw that carbon that's attached to this OH functional group, and then we see a hydrogen here, and then one R group. So because there's only one R group attached to the carbon with the hydroxyl functional group, we would call this a primary alcohol. And then you can see here, if this was our carbon that we were to draw out, we would see that carbon, the alpha carbon, that's the first attached to that hydroxyl group, is attached to now two other R groups. We know that these are just generalized alkyl groups, so this would be attached to two carbons, the central carbon, and we would call it a secondary alcohol. So sometimes you'll see abbreviated primary, secondary, or tertiary, again, just like those alkyl halides. So now we were told, right, when an OH group is attached directly to a benzene ring, we call this class of compound a phenol. So this is phenol, just phenol itself, when we have a benzene ring with that hydroxyl group. But we can use phenol as a parent here. So phenol is given in red. So this is our parent. And then we would name this would be our carbon 1. Then we name our substituent. So this would be carbon 2, 3, and 4. We went this way because we want the lowest numbering system, or else we would have a 4, 6 chloronitro. But in this case, we have the correct compound nomenclature because our phenol is given that hydroxyl group priority on carbon 1. Nitro is the next closest. And alphabetically, the chloro substituent comes first. So even though it has the locant 4, we place it first due to alphabetizing the substituents. So some alcohols that are commercially available and important, one is methanol. This is our simplest alcohol, right? It only has a one carbon chain. And this is produced in the billions of gallons a year. And it can be made from CO2 and H2. And you can see that in the chemical formula where this came from, right? We have all the starting materials. But it's good to note some specifics about methanol. It's commonly called wood alcohol because it can also be made from a wood source as well. So you might see that common name, but it can be used as a solvent. It's a polar solvent. It's also used as a precursor in chemical syntheses. So it's a starting material, something to make something into something else. Or it can be used as a fuel. It's combustible, it burns. So it has all these common uses. Also, ethanol. This is now more commonly known as a drinking alcohol. So that's listed down here. So not the alcohol that you drink that's not methanol. Do not drink that. It's poisonous, even in small quantities. But ethanol, this can be consumed. We ferment grains or fruits. So wine is also contains ethanol when we ferment grapes. And in the industry, ethanol can be used for other reasons, such as solvents, chemical syntheses, or even fuel. You might have seen some ethanol additives to gasoline. for example. And when we use ethanol in other forms than drinking, it's called denatured. So other things are added to this ethanol to make it non-consumable by humans, and that bypasses heavy taxing. So when it's made for industry to keep the costs down, to use it as a solvent, for example, they denature it, and that avoids anyone being tempted to drink it, or because now it's poisonous, just like methanol. So let's take a look here. This next slide, another common compound, isopropanol. This is poisonous, but this you might find in your medicine cabinet at home. It's the rubbing alcohol. It can be made by hydration of propylene for industry uses. So we have it as a solvent. You might see alcohol prep wipes. Those are antiseptic use. Those have isopropanol. Isopropyl alcohol is another name you might hear, or sometimes even as another gasoline additive. Anything to get that higher octane rating. So we have here some physical properties to discuss of alcohols. These are also covered in section 12.1. So we know that an OH group, the alcohol functional group, can hydrogen bond, right? This can hydrogen bond just like water. So these are just two generic alcohols here. So they could be the same alcohol, the same R group, or different R groups, but the end that has the hydroxide functional group, that can hydrogen bond. So another thing to compare are the boiling points here. And they're explained because of this hydrogen bonding why ethane would be so low. It just has those van der Waals forces, those London dispersion forces that all compounds have. So alkanes included, being nonpolar. And we see a very low boiling point here. So ethane is actually a gas at room temperature. We also have a fairly low boiling point for fluoroethane, but it has increased. Now we have a polar compound, so we're increasing those intermolecular forces. Now we have dipole-dipole interaction, so the boiling point increases. And then when we have the capability of hydrogen bonding, then we have the higher boiling point of ethanol, which exists in liquid form at room temperature. It's still a fairly volatile compound, but it can remain at liquid at normal room temperature conditions. So let's take a look at another physical property, the miscibility, or the solubility in water, right? So how well this alcohol mixes or is miscible with water. We have in alcohols, we have the hydrophobic region, right? So this is water loving. Oh, I'm sorry, hydrophilic region rather. This is water loving, these hydroxide groups. And then we have our hydrophobic region, which is full of these nonpolar R groups, the alkyl portion. So hydrophobic regions are not as water soluble, as you might have guessed, as the hydrophilic regions. And depending on the size of your alcohol, for example, down here, those with large carbon chains would not readily mix with water as the smaller alcohol chains do. So methanol and ethanol, for example, those are 1 and 2 carbon chain hydrophobic regions. So those would still mix fairly well with water. So we'll continue with the next section, which reviews the acidity of alcohols and phenols and alkoxides as well.